Hello 8th grade students, welcome to the final lesson this week. Go ahead and please take out your math notebooks and turn to a clean sheet of paper, name today's date. Let's go ahead and observe our objective today. I can define and evaluate cube roots. Now previously we've talked about Pythagorean theorem. Today we're moving on to a different formula. Now previously we worked with square root. The reason why it's called a square root is because outside this bracket there's a little 2. And sometimes it is not stated there's a 2 there. But now we're going to be delving into not 2, we're going to be moving that up 1. What I have here is called a cube root. Cube roots are very interesting in that they do not follow the same pattern that we have been using with perfect squares, with just seeing that little square root sign. Cube root is a little bit different. Cube root deals with taking something to the third power. For example, if I looked at 8 and I were to ask you to give me the cube root of 8, what would you tell me? Well, on your calculators there's a button for cube root. But another way to look at this, if we were to, let's say, break apart 8, the cube root of 8, any guesses on what it would be? Correct. The answer is 2. Now you're probably wondering why 2 is the cube root of 8. And that's quite simple, really, because 2 to the third power is just 2 times 2 times 2, which is 8, because 2 times 2 is 4, 4 times 2 is 8. Yes. What's the cube root of 1? 1. Because 1 to the third power is really 1 times 1 times 1. What about 27? Any guesses on what the cube root is of 27? Correct. It's 3. Why? 3 times 3 is 9. 9 times 3 is 27. Cube root follows an extra step in solving and looking at how numbers can be simplified. Let's go through a couple more examples. Now let's say the cube root of 50. Got any idea what the cube root of 50 would be? Well, first of all, 50 wouldn't end up with a whole number. Why? Because nothing times nothing times nothing would give me 50. But if I did the cube root of 50, once again, we get a decimal. So I would get 3.684 and so on. And like I talked about previously, when you're dealing with a decimal, you always want to round. So again, we'll put the funky equation sign. You always want to round to the nearest whole number. So if I rounded it, the cube root of 50 would give me 4. What about this one? What about the cube root of 162? Anyone? Well, again, if we plug in 162 and we take the cube root, we end up with 5.451. If we were to round that, we would get 5.4, which would round to about 5. Now, here is another question I have for you, 8th grade students, is what happens if we have the cube root of -1? What would the answer be? Any guesses? Well, in your handy-dandy calculator, let's plug that in, shall we? And let's take the cube root. What do you end up with? That's correct. A -1. Now the question on everyone's mind is probably, wait, whoa. Before, when we square root a negative number, or a negative times a negative, we get a positive. Because we're having to take that cube root, it remains the same. So any positives will remain the same, and any negatives will remain the same. Nothing changes. All right? Let's go ahead and look at your exit slip, shall we? Go ahead and do the cube root for the following three numbers. Go ahead and do the cube root. So the x to the third power equals 20. X to the third power equals 1,000. And x to the third power equals 81. What is the cube root for the following three problems? Go ahead, I'm going to have you pause the video right now to answer these three questions using your calculator and using the cube root function. Okay, let's go ahead and solve it, shall we? Once again, now instead of doing square root, we're going to do cube root, so we're going to add a 3 there. The cube root of 20 we round it, we get 2.7144. If we rounded it, we'd get 3. The cube root of 1,000 is going to give you a whole number, 10. And the cube root of 81, again, we get a decimal, so let's round it. So we get 4.3. If we round to the nearest whole number, we end up with 4. Your homework in Google Classroom will deal with using cube roots. Join me next week when we look at more cube roots and look at how this plays into using Pythagorean theorem and other geometric functions. Stay tuned.